If you forgot to test this bug, then I'm here to remind you. This bug allows hackers to steal session tokens, and that can even lead to account takeovers. So what are we talking about? We are talking about CORS. So this video will be covering CORS misconfiguration, means cross-origin resource sharing, and if you don't know about it, don't worry, we'll talk about it first and then we'll move to the misconfigurations. But before we move on to cross-origin, what is origin in the first place? Origin refers to the combination of scheme, such as HTTP or HTTPS, domain, like www.example.com, and port, if specified, of a web application. So, it contains three parts, as I mentioned: scheme, domain, and port. So, when combined, these elements form the origin of a web application or web page. So what do we consider same origin? Same origin is basically, let's say, example.com, and it has https://example.com, which is on port 8080. Okay, now any other site that has the same domain name, protocol, and port number means it is same origin, and requests from these origins can pass through. So basically, by default, browsers enforce same origin policy for protection. Means only origins that are same would be able to share pages like JavaScript pages or whatever. But in modern web application, it's not possible, right? Because we need to share cross-origin stuff. For example, we want to share files from different origin, like third-party files or CSS files for designing. We cannot just put everything there, right? So to make it flexible and to make web designing more easy, or make the backend communicate more easy, so cross-origin enforced by browsers that allows one origin to send request to another origin based on certain conditions. So it only allows that if there are CORS headers. So let's say the first header we have is ACAO header. So this header defines what origins are allowed, means what origins can access the resources. So you will see this header in the server response, which will include different origins along. You can also see sometimes asterisk symbol, which is a problem actually, because it means any origin is allowed. So if you see that, it's actually a bug. But there's another header that is called access control allow methods. It defines what HTTP methods are allowed, like get, post, put, or whatever. And there's something called access control allow credentials. And this one is also very important because this also defines if credentials should be passed to the request or not, like session cookies or tokens or passwords, whatever. Okay, before we move on more to the reports, let's first understand how CORS vulnerability works. So I have this lab from both Swigger, and I'm going to show you a quick demo. I won't take much time. Okay, so let's go to my account, and I have my HTTP history here, and you can see my account. This is get request, and not much interesting here because we're not logged in. So let's just log in real quick. Okay, so now that we're logged in and we have been provided with an API key. So the goal of this lab is to get the API key of administrator. So to do that, we have to exploit CORS here. So if I go and see this HTTP request, nothing interesting here as well. But yeah, this is the one that is interesting. And what's more interesting is access control allow credentials true, means it will allow credentials to pass through these requests. So we have to test if access control allow origin is available or not. I mean, if we can provide our own origin. So let's send this to repeater. This is a normal request. Okay, let's just add header here. Origin, because it's not present here, you can just manually type it. And now you can provide your own origin that is controlled by the attacker. So it could be something like this, and all you have to do is test if this value is reflected in the response of the CORS header or not. So send this request, and you can see it's not reflected. So let's remove it, and there's another thing we can try that is null. As you can see, the header says, the title says CORS vulnerability with trusted null origin. So this is another thing you can try. If you don't see it reflected, just send a request, and you will see that access control allow origin here with the value null means we can exploit this. Okay, now just to simply exploit this, we have to create a JavaScript or write a JavaScript that will send this request. So it will be an Ajax request, and we have to provide it here. So this is basically a tracker controlled URL. This is the URL. Okay, so I'm gonna quickly paste this thing here and just gonna change some value that is the lab ID. So here we have the lab ID. I think I messed up. Let me just copy it and Control Z. That saves the day. Okay, now that looks good because we want to send a request to account details that we have to provide the value here and then give the value true, because we want to send the credentials, as you can see here as well, and then send the request. Also, we have to provide a value null here because we want to send a null request, origin with null value, right? Okay, so now we have to provide the exploit server ID, which is this. Done. And then log question mark. So we have this key parameter, and inside the value of this key parameter we will have the URL encoded this body, which contains the API key and session. Great, everything looks good. As this is an iframe hosted on attacker controlled website, the attacker can just send the website URL link to the victim, and once the victim click on it, CORS request will be sent. So let's click on access log to see if we get any response here. Made a huge mistake. I still have to provide HTTPS. Same thing here. Okay, and this time after delivery we can see that the key has this value username, and then the whole thing we can just copy it. Oops. Yeah. And then go to decoder, click on smart decode, and then we have the API key and session. Okay guys, now that you know the basics, let's move on to some of the bugs that you can look for while bug hunting. So the first one we have here is this report, and we're going to analyze what's this about because this is one of the popular ones. Okay, so this one is reported to Zomato, but technically it is reported to Eternal. Eternal company owns Zomato. So the domain here is www.zomato.com, and the CORS misconfiguration could lead to disclosure of sensitive information. So let's read the description a little. An HTML cross-origin resource sharing policy controls whether and how content running on other domains can perform two-way interaction with the domain that publishes the policy. Policy is fine-grained and can apply access control per request based on the URL and other features of the request, blah blah blah. You know what? Let's move to steps to reproduce. Okay, so we have the request here. You can see this is the path. Okay, and we have cookies here and stuff, and this is a response. So in the response, we can see access control allow origin header, access control allow credentials, which has a value true, means the credentials can be paused, and then access control allow methods that has these two methods, and then access control allow headers. Okay, now interesting thing to be noted here is access control allow origin has this value developers zomato.com. Now you must be thinking that's it looks weird because it is custom made by the guy who reported it, AHD911. So basically, I think the access control allow origin original value would have been zomato.com, but there is a lax check in the backend. For example, if you put anything before zomato.com, it will also take that as well. So anything like Medusa, zomato.com, it's going to take that. So it's not checking the prefix, it's just checking if zomato.com exists or not, or maybe it's just checking zomato exists or not. So here we have the bug. Now to exploit this, now this alone could not be a very major issue, but what makes it a major issue is access control allow credentials is true as well. So when it is true and access control allow origin header is there as well, let's see what happens. It didn't add the POC, but to exploit this, it must have created a JavaScript file. Yeah, here. Open any browser, go to this, then inspect the page and go to console, run the following code in the console, you'll find it pops up user information. So this is the XML HTTP request, which is being used to open this, to send a request to this. Now the thing is, this origin means developer x zomato.com is sending a request to zomato.com, and it's going to give back a response, and the response will contain credentials. As you can see, it says rec.with credentials equals true, and this is going to alert that response text, basically the credentials in the response. Okay, this POC is probably not making much sense because you couldn't see the code, but I'll show you the next report in which there is the proper HTML exploit you can see. That was a nice bug. It was resolved, but the bounty was, I would say, kind of less, $550, but I guess it's okay. It actually depends on the company how much they award for medium, low, or high. But okay, we got this as a reference. Pretty good. The next one up we have is reported to Nord Security, and it's a duplicate, but duplicate means valid, guys. Anyways, so this goes with title CORS misconfiguration on nordvpn.com leading to private information disclosure account takeover. I told you it leads to account takeover, and they should definitely take it seriously, though we cannot see the bounty here, but you can figure out. Okay, so some basic definition, but we already know that. So let's move to the steps to reproduce. We have the request here, get wp-json. Okay, in the response we have this, and we have access control, allow header, origin methods, credentials, and headers. So the one with our interest is access control allow origin, and it contains this value http://iamsoevil.com. I'm not evil, I was just reading. Of course, seems like it is taking anything now. It's not even just checking the prefix or suffix, it's literally taking anything. I wonder if the original value was like asterisk. It has to be. So yeah, this is a script, and this is a similar script the guy in the previous report also used. As you can see, this is the script, and it sends a request, a get request, you can see, to this path with true, with credentials true, and then it gets a response, and then it alerts the response, which will contain the credentials. So again, this is pretty crazy, and the one that is exploited in the wild. Okay guys, now that was some good real examples, but now let's have a look at how you can approach while you're testing for CORs. So we got this gitbook.io website, and we have this application security cheat sheet for CORS misconfiguration. So let's have a look at it. So actually I forgot to mention about one thing, that is pre-flight options. So this is actually a mechanism that allows CORS to check if CORS request is safe to send from one origin to another, like before actually making the request. So it does that for more complex HTTP requests like put or delete. So it will send a request to check if CORS allowed or not, and then it will actually send the original request to perform that action. Okay, so we have simple requests do not trigger a CORS pre-flight. As I told you, one of the allowed method is get, head, and post. And the only allowed headers which will be set manually is these headers. The only allowed values for content type is these. And there we talk about pre-flight request. So pre-flight request first send the HTTP request by the options to check if CORS is allowed or not, and then it actually sends the actual request. Okay, so these are some actually basic notes about CORS if you want to learn, and I think it's really good resource. But these are data about the headers. But here we have the misconfiguration part. So, breaking TLS with poorly configured CORS. Suppose an application that rigorously employs HTTPS also whitelist a trusted subdomain that is using plain HTTP. For instance, when an application receives the following request, like this, /API request API key, and this is pretty sensitive, and it has this origin http:// trusted subdomain.onelevelwebsite.com. An application responds with this. Now it says, okay, this is allowed in the access control allow origin header. We can see that, but it is HTTP, right? A victim user can make a plain HTTP request, and attacker injects a redirection to this. A victim browser follows the redirect, attacker intercepts the plain HTTP request and returns a spoofed response containing CORS request to this. MITM attack. So I don't think if you report this, they're gonna take it. So I'm going to skip this, but this is good to know though. Next up we have is broken parser. Most servers use basic string operations to verify origin header, but some parse it as URL instead. So in Safari, http website.com person60.attacker.com is a valid URL if CORS request originating from the URL. The origin header will look like the next one. Is this behavior still valid in Safari? I'm not sure about it. Like if you pass something like this, the browser is going to parse this header and omit this part. That's kind of crazy. But I guess we can try that out. I think that's why people kind of like forget to check it, because there is not much in it, and most of the time the applications are usually secured. But I think you should definitely still check it out. Like maybe there's a chance if you send a different origin it will accept it, so you can have a bug, right? But definitely put it in the checklist. And you can definitely read this everything, because there's a lot in it. I cannot explore like everything here, but if you want, let's move to this one, server-side cache poisoning. If the application reflects the origin header without even checking it for illegal characters like this. So HTTP header injection vulnerability against. Now this is itself another vulnerability, and I've kind of made a video on this as well. This is also kind of like HTTP request smuggling, but that's a whole different thing. And I was actually thinking to make a video on request smuggling. If you wanted to, let me know in the comment section. So Edge viewed this as a valid HTTP header terminator. An Internet Explorer sees a response is this. Okay, so you put this here and then add a content type header, and it's going to take that value, whatever value you provided in the origin. This is not directly exploitable because there is no way for an attacker to make someone browser send a malformed header, but you can manually count this request, and the server-side cache may save the response. This is kind of a bit controversial, like not something as solid you want to report. The reports I showed you, those are the ones that are solid enough to report, rather than these conditions. These conditions maybe you can keep in mind, or could be good in a pen test, but I wouldn't say really good for bug bounties. But just want to point these things out for you so you can understand what to do and what not to do. Okay guys, that's it for this video. I didn't want to make this video too long because a lot of things going on in my life right now, and I barely managed to make this video, and hope it gets the reminder to check for CORS sometimes as well. So hope you enjoyed watching this video, and I'll see you in the next one.